Okay, in this video, let's continue with our discussion of conceptual data modeling and focus on representation of relationships. So going back to the diagram here that we had used as an example, this is a sample conceptual data model represented as an entity relationship diagram. And in the previous video, we talked about the entities, the things about which we store information. And in this tutorial, we will focus on relationships. Now, just visually, you can see that these entities, these boxes, some of the boxes have lines connecting them, suggesting that the information in those two entities are related. The content in those two entities are related. For example, you have some kind of a line here between customer and meter, and it suggests that meters are linked to customers. So each customer has meters for the utility billing, and similarly you see a line between reading and meter, suggesting that each reading is associated with a meter. Okay, but a meter might be associated with many different readings. So these lines that you are seeing between pairs of entities, these suggest that there is connections in the content, there's association of the content in those two entities, and that's what we mean by relationships. So the content in the two entities are related, and that's what we mean by relationships. So in this video, we will focus on relationships. What do these lines mean, and what do the symbols on the lines mean? How do we characterize relationships? So that's what we are focusing on. So let's first look at relationships. Just a few examples. Now, if you have an entity called customer, for example, and you have an entity called product, so you could have a box which says customer. You could have a box which says product. These are two different entities. And we know that one relationship that you have between customer and product is that customers buy products. Okay, one customer can buy many different products, and one product could be bought by many different customers. So these two entities are related. You can have more than one relationship between two entities. A customer couldn't just buy a product; they might return a product. Okay, so one customer could return multiple products, and one product could be returned by many different customers. So the basic idea here is that in a conceptual data model, you have this thing called entities. These are things about which you store entities, and then this content in the entities are related. So the relationships among the different entities, and that's what we are going to focus on. So the first property of a relationship, first of all, the way it is drawn graphically is by a line connecting the entities. So here you have one entity called supplier. You have another entity called quotation. Now notice that for the entity supplier, we haven't shown the attributes of supplier. And for our discussion right now, we don't need it. So this is sort of a abbreviated representation of the entity called supplier. Similarly, for the entity called quotation, we haven't shown all the attributes of quotations. For example, there could be the date of the quotation, the dollar value of the quotation, and so forth. But for our discussion, since we are focusing on relationships, we don't need those details. So we have two entities here, and basically relationships are shown by lines connecting the entities. Okay, moreover, and historically the relationships have been shown to these diamonds. So you have a line with a diamond, and there has to be a name. Every relationship must have a name. Relationships must have names. Okay, so the first property of a relationship is how many entities does it connect together. All right, so the most common type of relationship is what's called a binary relationship. It's a relationship that connects two entities. Okay, so you have a line between two entities. That's by far the most common type of relationship that we encounter and that we see in databases. Okay, but that's not the only one. You could have a situation where you have a relationship among three entities. So here you have an entity called mother, you have an entity called father, you have an entity called child, and you have a relationship among these three entities called parents. Okay, so a child has a mother, a biological mother, and a biological father. Now let's say the mother and father get divorced, then the child could have a different mother and the same father. So you have here you have a diamond representing the relationship, and every relationship must have a name, as we mentioned. So this is called parent, and in this case you have a relationship that connects three entities. Okay, so the previous example that we saw, this is an example of a binary relationship because the relationship connects two entities. If you have a relationship that connects three entities, it's a ternary relationship, and theoretically you could have a relationship that connects four entities and even five entities, but they are pretty much, that you will not run across them in practice. So in practice, by far the most common type of relationship that you will encounter is the binary relationship, and occasionally you might run into a ternary relationship. Okay, so the first attribute of a relationship is how many entities does it connect together. Okay, as we said, the most common type of relationship is the binary relationship. Okay, now you can have a unary relationship also, where you have an entity. Let's say I have an entity called course. Okay, and you could have a relationship. Let me clean this up. You could have a relationship of an entity with itself. Okay, and I'll call this relationship prerequisite. So one course could be a prerequisite for other courses. Okay, so you have here you have an entity related to itself. This is an example of a unary relationship, but as I mentioned, I've been mentioning so many times up to now, by far the most common type of relationship that you're likely to encounter is the binary relationship. Okay, so up to now, what are the things that we have mentioned about a relationship? Every relationship must have a name. When you have an entity relationship diagram or an entity relationship model, relationships connect the content of one or more entities, and you show them by lines in the diagram, and every relationship must have a name. So the first property of a relationship is how many entities does it connect. So you have unary, binary, ternary, and higher order relationships. By far the most common one is the binary relationship. Okay, now so in terms, so another property of a relationship is what's called cardinality. Okay, and the word cardinality refers to count. Okay, and since the most common type of relationship is the binary relationship, when it comes to cardinality, there are three types of binary relationship. There's something called a one-to-one relationship, a one-to-many relationship, and a many-to-many relationships. Okay, so the maximum cardinality is the maximum number of entity instances that may participate in the relationship. So that's a technical definition. Let's see an example of these cardinalities. Okay, so we are talking about another aspect, another property of relationships, and that is their cardinality. Okay, so let's look at this particular relationship. Do you see that this relationship is binary? You have an entity called employee, you have an entity called locker. So this is a binary relationship since it connects employee with locker. So you have this diamond, and then you have this name of the relationship called locker assignment. So a locker is assigned to an employee, but we are specifying here that the relationship is one-to-one. Do you see? One. So the cardinality is one-to-one. What this means is, what we're trying to say through this picture, So the symbols is one employee can have at most one locker. You see, maximum cardinality. How many at the most? So one employee can be assigned at most one locker, and in the reverse direction, one locker can be assigned to at most one employee. Okay, so that's the 1:1. So that's the maximum. So an employee may have no more than one locker, and a locker may be accessible to at most one employee. Okay, so this at most is very important. So let me repeat what I just said, the symbols about cardinality. So when you see this 1:1, what that means is one employee can be assigned at most one locker. And if you go, that's in one direction. If you go in the reverse direction, one locker can be assigned to at most one employee. So a locker could be unassigned, it's empty. Okay, it hasn't been assigned to anyone. And there could be an employee who doesn't have a locker. But if there is an assignment, then an employee can be assigned to at most one locker. Now, there is nothing sacred about this 1:1. You might have a club where an employee says, hey, I'm willing to pay for 2 lockers, and then the business rules would say that an employee can be assigned to more than 1 locker. So let's say 2, or let's say the rules say that you cannot be assigned to more than 3 lockers, so an employee can be assigned to more than 1. So there's nothing sacred about this 1:1, but if an employee can be assigned to no more than 1 locker, and if a locker can be assigned to no more than 1 employee, then the relationship between employee and locker is 1:1. So in this discussion, this narrative that we have gone through, I have explained to you what a 1:1 cardinality means. This is the maximum cardinality. Okay, so let's look at a few more examples here. Let's take a look at another type of maximum cardinality, that is 1:many. Okay, so here you have 2 items. One is called 2 entities rather. One is called an item, the other is a quotation. So an item could be, let's say, a drill that you're going to store in your shop, and this other one is a quotation. So let's say you want to buy a drill from different suppliers, so you send out a request to 5-6 different suppliers, and each supplier sends you a different a quotation for that particular item. So 1:n. Again, do you see that the relationship must be given a name? The name of the relationship is item quote. This relationship is also binary because it connects 2 entities. So how do we read this symbol 1:n? Let's go in one direction. When we go from left to right, the way I would read this notation is one item can have at most many quotations. N means many. Okay, so one item can be associated with at most many quotations. Okay, now if you go in the reverse direction, you see it's the 1. Okay, so we'll say one quotation can be associated with at most 1 item. So that's where the 1 comes from. Okay, so let me repeat. When we go from left to right, we're looking at the N. So one item can be associated with at most many quotations, because there are many vendors who are responding to your request. One vendor is saying, I will sell you this item for $5. Another vendor is saying, I will sell it to you for $5.50. So the different quotations for the same item. Okay, so it's like you put your car out on eBay for bid, and one potential buyer says, I'm willing to pay $5,000 for it. Another person says, I'm willing to pay $6,000 for it. So the different quotations for the same item. Okay, so when we go from left to right, 1:n, the way I read it is one item is associated with at most many quotations. The N is closest to the quotation. Okay, so one item is associated with at most many quotations. So this symbol that you're seeing is closest to the item. So when I go in the reverse direction, I will say one quotation is associated with at most 1 item. Okay, So this is 1:many. So so this is an example of 1:many. Let's look at the third type of cardinality, which is many-to-many. Okay, and is represented as n:(m). That's the symbol that's used. So here you have item, two entities. One is called an item and the other is called a supplier. And we are saying that one item is sourced from different suppliers. So how do we read this one, n:(m)? Same logic as before. When we go left to right, the letter M is closest to supplier. Okay, so we will say one item is sourced from many suppliers. That's where the M comes in. Okay, one item is sourced from many suppliers. That's going left to right. Now if you go right to left, we will say one supplier sources many items. So one supplier supplies many different items. So this is a many-to-many relationship between two entities, item and supplier. All right. So let me give you a different example over here. So let's say we have two entities. One is student and the other is course. And I draw this little diamond and I say takes. And I will argue that this relationship is many-to-many. Why? Because if I go in one direction, one student takes many courses. Okay? And if I go in the reverse direction, one course is taken by many students. Okay? So this is a many-to-many kind of relationship. Okay? So I hope the degree of the relationship, whether it is unary, binary, or ternary, okay, you have understood how that is different from the cardinality of a relationship. So we've talked about maximum cardinality. Now we have to talk about minimum cardinality. Okay, so cardinality refers to count. Again, let's come back to the to our example. So we are continuing our discussion of cardinality, but now we are talking about minimum cardinality. So when we are talking about maximum cardinality, I hope you remember the symbols were within that diamond. The symbols were put within the diamond. Now I hope you're seeing that the two extra symbols have crept in here. There's one symbol here and one symbol here. These are next to the entities. Okay, and in one case you have a 0 and in another case you have a 1. All right, and these refer to minimum cardinalities. So I hope you remember when we were discussing the previous examples. Let me go back to one of the previous examples. The way I had described this relationship is one item is sourced from at most many suppliers, and then when we go in the reverse direction from right to left, the way I had described it is one supplier supplies at most many items. That's why the maximum cardinality was many-to-many. Now let's come back to this minimum cardinality. Where's the example that I was using? Here we go. So so here again you have the same two entities, item and supplier, but now we are going to focus on these two symbols on the outside edge of the line. In one case you have 0 and in another case you have 1. So what we will say over here is one item is sourced from at least one supplier. So this is at least. Okay, so an item must have at least one supplier. That's the minimum cardinality. So you can't have an item without a supplier. Okay, so an item must have at least one supplier. That's where this 1 comes from. Now if you go in the reverse direction, the way we say it is a supplier does not have to supply an item. So a supplier supplies at least 0 items. Now that may seem strange, but in practice that may be perfectly reasonable, because you may put a supplier in your database and you're not yet completely sure what are all the items that this person is supplied. Obviously, if after 6-7 months you still don't know what the supplier is supplying, that is not very useful. But there could be an initial stage in the database where you have the information about the supplier, but you don't exactly know what are all the items that this supplier is supplying. So when you go from right to left, the way you would read the minimum cardinality is that one supplier supplies at least one supplier supplies at least 0 items. So a supplier does not have to supply an item, but an item must have a supplier. So the minimum cardinalities are shown on the outside and the maximum cardinalities are shown within the diamond. That is how historically the entity relationship diagram was represented. Now, as it so happens, there are no, so there was this professor called Peter Chen from Louisiana State University who came up with these graphical notations. So these are called Chen diagrams, but also historically that's what they've been called. But there is really no standard notation for entity relationship diagram, and later on we will be using Visio as the software to draw these entity relationship diagram, and it uses a slightly different notation. And this is again is just slightly unfortunate that there is no standardized notation. But let me show you the more common notation that's used. That's called the crow's foot notation. Okay, so the crow's foot notation expresses the same information but uses slightly different symbols. So let's go back to the symbols that we have been using. So we have here 2 entities, one called department and the other called employee. Okay, and we have a relationship between the 2 entities, and we are saying, again, the symbol should be familiar to you. The maximum cardinalities are represented within the diamond. The minimum cardinalities are represented on the outside of the lines closest to the entities. Okay, so how do I read this picture? All we are trying to do is understand the symbols that show up in an entity relationship diagram. So the way I would read this diagram, again going from left to right, I would say one department is associated with at most many employees. That's the N. All right. And then when we go from right to left, remember that we are talking about maximum cardinalities. One employee is associated with at most one department. Okay. So the maximum cardinalities are shown within the diamond, and I've just described for you how to read them going left to right, right to left. Okay. So now let's look at the minimum cardinalities. Again, we'll go left to right, right to left. But now we'll look at the symbols on the outer edges of the lines. Okay. So one department is associated with at least one employee. So you see this one over here. So one department, I'm going right to left. One department is associated with at least one employee. So you cannot have a department without an employee. All right. But when we go right to left, one employee is associated with at least 0 departments. In other words, you could have an employee without a department, and that's not unreasonable, because let's say an employee has just been hired and they haven't been assigned to a department yet. So for a little while, an employee could be without a department. Okay, but again, it depends on the particular business or the particular organization that you're dealing with. Suppose your business is such that as soon as an employee gets hired, he has to be hired into a department. So you cannot have an employee without a department in your business, let's say. In that case, you would put a 1 over here, and you would say an employee is associated with at least one department. Okay, so all I'm trying to do is tell you how these symbols are interpreted. Now, this picture that you see on top is how ER diagrams used to be drawn originally when the professor who designed this, who came up with this concept, drew them. But over time, these symbols have changed, and really there are no standard symbols. There are many variations, but a very common set of symbols that's used, and that's used in Visio, is called the crow's foot version of the ER diagram. So again, notice that you have 2 entities, department and employee. Okay, so do you see that the minimum cardinalities still show up at the ends of the lines? Okay, so you have this line connecting the two entities, signifying that the two entities are related. There's a relationship between the two entities. So the minimum cardinalities are shown here. Now the symbols are at the two ends. The maximum cardinalities are here. Okay, so here's the 0, here is the 1. That's the minimum cardinalities. The way I would read it is going left to right. One department is associated with at least one employee. That's where the 1 came from. And if I go right to left, one employee is associated with at least 0 departments. So that's the inside symbols. Okay, now if I look at the outer symbols over here, outer marks over here, those are the maximum cardinalities. And that's where this, look at this symbol on the extreme side, this particular symbol, it looks like a bird's foot, a crow's foot. That's where the name crow's foot comes from. So this is a corrupted form of the letter M. You can think of this as a corrupted form of the letter M as well. So the way you would read this picture is one department is associated with at most many employees. Okay, and if I go right to left, one employee is associated with at most one department. Okay, so let me erase these symbols, and now I'm going to go right to left, left to right, and read these symbols together. Okay, so let me go left to right first. So I will say one department is associated with at least one employee and at most many employees. So at least one employee and at most many employees. Okay, so now I will go right to left. So I start off by saying one employee is associated with at least 0 departments and at most one department. Okay, so in the crow's foot symbol, okay, the inner symbol is the at least, and the outer symbol is at most. Okay, so the symbols should now be clear in terms of what the picture represents. I haven't yet discussed how to come up with the picture, but here's a summary of the different symbols that you're likely to see at the end of the line. If you see a symbol like this, that means at least one, at most one. Okay, if you see a symbol like this, this means at least one, at most many. If you see this, at least 0, at most 1. And if you see this, this is at least 0, at most many. Okay, so at least 0 means optional. Okay, all right, so these are the symbols that you will see. This is fairly large amount of material here, but we will work a lot of examples. Don't worry about it. So let's look at a specific example over here. So here you have 2 entities. One is called course and the other is called offering. So like MIS310, it can be offered multiple times in the same semester. It can be offered in different semesters and so forth. Okay, so let's look at this picture. All I'm trying to do is interpret the symbols that are there in the picture. Okay, so this is a very simple entity relationship diagram. In this diagram, you can see there are 2 entities, one entity called course and the other entity called offering. And for each entity, you have the attributes that are listed here. So for offering, we have the offering number, the offering location, which is presumably the room number where the offering is, and the time of the offering. And then for the course, you have different attributes like course number, course description, and the credit units for the course. Okay, so you have two entities, and these two entities are related. So there's a relationship between these two entities. So it's a binary relationship. Every relationship must have a name. We've said this at the start of this lecture. So the name of this relationship is has. So a course has offerings. That's what this line, this dotted line between the two entities represent. Now we are going to focus on these symbols at the end of the line, at the two ends of the line. Okay, so remember, the inner symbol is the at least, and the outer symbol is the at most in terms of cardinality. So this is a binary relationship because the relationship connects two entities, but now we're going to talk about cardinalities. Okay, so let's go from left to right. So the way we will read this is one course has at least 0 offerings and at most many offerings. So let me just explode this view. You have these are the two symbols that you're seeing at the end of the line. Okay, so going from left to right, we will say one course has at least 0 offerings, because you see that 0 there, and at most many offerings, that crow's foot, which is a corrupted form of the letter M. Okay, similarly, if you go from right to left, again, let me blow up this picture over here. You have a line, the relationship, and you have 2 vertical hash marks. Okay, so when I go from right to left, the way I read this picture is one offering is associated with at least one course and at most one course. At least and at most. Okay, so that's, I hope you understand now what these different symbols in the picture mean. Okay, so let's try another example over here. You have two entities. One, so again, reading it left to right, if we use the old notation for the entity relationship diagram, one employee is associated with at most many skills, and one skill is associated with at most many employees. So this is a many-to-many relationship. All right, so this is the at most. And these two symbols are the at least in the original type of symbols that we're using. So one employee is associated with at least one skill, and one skill is associated with at least 0 employees. So you could have a skill that is not present in any of your employees, but you shouldn't be having an employee who has no skill. So going left to right, the same picture on top is represented at the bottom using crow's feet notation. Okay, so look at these symbols on the two ends of the line. Of course, this line must have a name. So let's say employee has skills. So there will be a name for this relationship. Okay, so how do we read these two symbols? So again, let me blow up the picture. This is the picture that you had at the end. So when I go from left to right, I will say that one employee has at least one skill, that's the minimum, and at most many skills. That's the crow's foot. 1 M. Okay, so one employee has at least one skill and at most many skills. Now if I go in the reverse direction, let me take this picture here and I blow it up. It looks like this: 0 and then crow's foot. Okay, so if I go from right to left, I will say one skill is associated with at least 0 employees and at most many employees. So there could be a skill that none of the employees possess. Okay, so I hope the difference between the degree of the relationship, namely unary, binary, ternary, and the cardinality of these relationships, these are clear to you. So in the next tutorial, we will look at, we'll try out, work out several different examples of ER diagram. So I haven't shown you, coming back, just closing the loop over here, coming back to the database development lifecycle, database development process, I haven't shown you how to take requirements and come up with the conceptual data model. All I showed you is when you draw the conceptual model, it will be in the form of a picture, an entity relationship diagram. And all we discussed here is what are the different symbols that show up in the diagram and how do you interpret those symbols. So in the next video, what we're going to look at is, now that we know what the symbols are, how do I get from requirements to the conceptual data model? How do I draw the pictures with the different symbols?